Okay, Bismillah ar-Rahman ar-Rahim. Today we will talk about the hydraulics of water pumping systems. So the presentation outline will cover the following topics. First, we will give some definitions and classification of the pumps. Then we will talk about the main parts of the pumping units. Then we will give some introduction about how to calculate the pumping head, and we will give some description about the first assignment, which is related to a site visit. So let's start by first defining what does it mean by a hydraulic pump. A hydraulic pump is just a hydraulic machine that is used to increase the total energy of the pumped fluid and the pumped liquid. So the question here might be asked, why do we need to increase the total energy of the water or the pumped fluid? This might be because of many reasons. The first reason that we can say is that to raise the water from a lower level to a higher level. So in order to do that, we need to increase the energy of the pumped water. The second reason might be, for example, if we have a tank that is higher, which is tank A, that is higher than tank B. So if we connected tank A and tank B, so the water will go from A to B directly through the transmission line without the need of any pumping. Imagine that the flow that is passing from A to B is, say, 100 liter per second, and this amount is smaller than what I need. So one of the actions that I might take is to install a pump. And if you install the pump in this case, so the flow that is passing from tank A to tank B will increase. So in this case, the water pump is used not to raise the water from a lower level to a higher level. The pump here is used in order to increase the flow rate that is transmitting from tank A to tank B. If we have like this statement, what do you think about it, whether it is correct or wrong? The main objective of a water pump is to increase the kinetic energy of the pumped water. So what do you think, if it is correct or not? So the answer is this statement is wrong. The main objective of the water pump is to increase the total energy of the pumped water, not the kinetic energy of the pumped water. Okay, let's now talk about the pump classification. The pumps can be classified into two main categories. The first category is the displacement pump, and this is animation of one of the displacement pump, which is called the Belanger pump. As you see here, we have a piston and we have a ram, and this ram is reciprocating back and forth, and by this action, the ram is physically displacing the water or the liquid that is pumped, and as a result of that, the liquid is moved. So the pumping mechanism here is based on the physical displacement by the action of the ram. Another example here is the gear wheel pump. As you see here, we have two gears, and the water is trapped between the teeth of these two gears. And if the gear is rotated, the entrapped water or liquid will be forced to displace physically to the other direction. Let us look at the animation. And if we look at the animation here, as you see here, the liquid is trapped between the teeth of the gear, and it is physically transmitted to the outside or the outlet of the pump. So both of these pumps are under the category of the displacement pump, because the methodology of pumping here is to displace the liquid physically. There is another type of pump which is called a rotodynamic pump. In the methodology of rotodynamic pump is the action of the centrifugal force. If we look at, or if we imagine that we have a child or a person, and this child or person got a rope, and he attached a rock at the end of the rope, and he started to revolving the rope. As a result of that, the rock will be affected by what's called a centrifugal force. And if this child or this person let the rope to go freely, so the stone will be moved outside by the action of the centrifugal force. The same will happen for the centrifugal pumps. Look at these centrifugal pumps here. The water here is coming from the inside, and because of the action of the impeller, which is revolving, as a result of that, a centrifugal force will be generated acting or acting on the particles of the water and causing the particles of the water to like expelled outside. So the pumping mechanism here is because of the action of the centrifugal force, not because of the physical displacement of the water particles. So this is what's called the centrifugal pumps or the rotodynamic pumps. So a question here might be raised, why as a civil engineer we are interested in knowing this kind of classification? Actually because of the different applications that each category will be fitting in. Like for example, in case of displacement pumps, the displacement pumps are very suitable for the cases where we have high viscosity or we have high temperature of the liquid to be pumped, and also we have in case of having a fluid with high solids, like for example like the concrete, pumping concrete, or like pumping raw sewage. In this case the best application will be using the displacement pump. But in other cases, it will be the rotodynamic pump that is suitable for this case. In the majority of the applications for the civil engineers are the rotodynamic pumps, so we will gonna focus on these rotodynamic pumps. So let us now talk about the calculation of the pump head. Imagine that we have these two tanks, and this is a suction tank, this is a delivery tank, and this is a transmission line, and this is the pump. And the vertical distance between the suction tank and the delivery tank is called the static head. So how can I calculate the required head of the pump in order to transmit the water from the lower tank level to the higher tank level? If you imagine that we want to the water to move from the lower tank to the higher tank, so the particles of the water needs like to first to beat the static head, second thing to beat the friction losses that will take place while moving from the suction tank to the delivery tank, and also to beat the local losses that comes from the bends, from the exit and inlet losses, from the elbows, from the valves, from the fittings. So all of these losses will be included in the calculation of the head of the pump. If we imagine that we would like to draw the total energy and the hydraulic gradient line of this system, so the total energy will be something like this. And as you see here at the pump location, the lower total energy is just in the suction of the pump, and the higher total energy is just took place at the delivery of the pump. The vertical axis from the lower to the higher is called the head of the pump. This head of the pump is equal to H static plus the friction losses plus the local losses. So now I could say that H pump equal to static head plus the friction head losses plus the local head losses. And if I put this formula into like mathematical expressions, so I would say H static equal to H pump equal to H static plus sigma, the local losses coefficient, plus F multiplied by L, which is the length of the pipe, divided by D, which is the diameter of the pipe, multiplied by V square over 2G. V is the velocity, the average velocity of the pipe, and G is the gravity acceleration. The friction coefficient F is the friction coefficient of the pipe, and it could be like calculated using a Moody chart or using SWAM and GN formula. So the assignment number 1 for this lecture will be related to conducting a site visit. So the students will be asked to select a location that includes a pumping system, and to carry out a site visit for this location, and to do some visual inspections, some visual calculations and measurements to prepare a 2 to 3 pages report. Intended learning outcomes of this exercise is first to allow the students to apply the theory in practical life. The second thing is to teach the students how to like do some work in groups. The students will be asked to formulate like groups of 2 or 3 students and to select a pumping site by themselves. This might be their own homes or houses, and to do some simple visual inspections and some simple measurements. to calculate the head and to draw the system curve of the pump, and also to prepare a 3 or 2 pages of report, a simple report that summarizes the conclusion of this site visit. Thank you.